All right, so I'm ready. We're going to get started. First of all, with the assignment, how are we doing? It's all good? Okay. Okay, so if folks that are online, that you have concerns regarding the assignment, let me know, and I don't mind giving an extension, because we had AX that was a bit late. So otherwise, I'll keep moving with the lab for the day. Let me see. Goes here. 7 start. Here we go. Start sharing the screen on the desktop, and hopefully I'll try to do a better job at getting this on screen for everybody. All right. Okay, so I already have this cloned, so we can get started. I did already the npm install, so it seems to be all good. So I'll do the npm run serve, and then we can go on. Okay, we'll start with the lab 1. Okay, so this one is a little bit of playing with the color model, so that we understand a little bit how these colors work, and we also understand the after images, and specifically how to find out which colors are going to appear in the after image using the color tool that we have here. So let me close this. So maybe we just take a look at this part first. Okay, so this is the RGB color model with the primaries that are R, G, and B, and then we have the cyan, magenta, and yellow for the secondary colors. Now, when you look at an after image, what happens is that the cones that are responding to a given color get saturated and they get tired. And so the color to which they correspond, for instance, here the green cross that is corresponding to the green ear, is going to have some trouble firing as soon as we switch to the white picture. And there, what happens is that because the green is not responding, but the red and the blue are still available, then we're going to get the complementary color of green, that is the magenta. Okay, so this is what happens with the second cross here, where we get the magenta for the green, and the red is going to give the cyan for the same reason. Okay, so if you want to predict the colors, basically it's quite simple. So you just look at the secondary colors in the additive color model. So you don't want to use the subtractive because here the display is an LCD, and so that's the model that that works for this. And for all what we're doing is basically the same model that we're going to be using. Now this is how you can predict it using the colors here in the additive color model. However, in this, I want you to experience it. So what I did is put together this little experiment here, where you basically can try it on yourself. So we're not going to do it during the lab unless you want to do it on your own. But the way this upper images work best is if you keep your sight fixed on, say, the center of the cross, and you don't move your eyes. Because as soon as you move your eyes, it compensates for this fatigue of the photoreceptors. So you give them time to recuperate. And that's what we do naturally with the saccade movements. Okay, so that's why normally this doesn't happen, but you can crop the display so that you get some effect of that, and probably you have experienced it already. So you see that here it does some instruction. It says fixate at the center of the cross for 15 seconds, then look at the white background, press space to reset. So this is because in the code we need to go and fix that. So here I'm opening it on the side. And the way we do it is that we just follow the breadcrumbs here with the red bag. So that we basically make this we turn this into a working example. So as you do, you'll see that there are some documentation that has to do with some of the tools that we're using to do this, that you might be familiar, but if you're not familiar with them, you should definitely go and look at docs. So this one is for the free selection, because we're just doing using the selection mechanism. And here we're kind of tricking D3 into being a tool to query the DOM. And so what we really want is the node. So now you remember that the D3 doesn't return you a selection that is the actual node. It's a selection object that D3 handles. But what we want is the node in the DOM. So to get the node in the DOM, you need to do this selection.node method that is going to return it to you. Okay? And that's what is used here. So you can use this information to basically fill in the blanks here, and you can just go ahead and explain it there for the grade. The same thing with client width and client height. You can get that. The last bit of piece here is this get computed text length. So if you look how this is used, so you see that here the text is centered in the middle. And when this text is created with dummy. That is right here. And you see that we set it at 1010. Yeah. So 1010 is somewhere up here. And this is relative to the bottom left, unless we change the anchor. So the text is really very close to the top left corner of the SVG that here takes the whole page. So what we want is to automatically put it center in the middle. So for this, we need to know what is the size of the text when rendered. And this function from the JavaScript, the browser API, it provides you with that. So here we get the actual text length when rendered in the page. So we can set it up correctly. So I'm moving here. So all these are fairly simple to get going, but you may want to understand how they work. So here we want to do a transition after 15 seconds. So you remember that the delay is in milliseconds. So this is 5 seconds. So if you want to wait 15, we need to put a 1 in front. But I'm going to leave it at 5, otherwise we need to wait for a long time. And here, can somebody tell me what this is doing? So here we have the green cross, right? So and the red background. So what we want is to materialize the after image. So we need to display a white background, right? So here you see that what are we doing? We're transitioning what? Help. It's written. There's VG, yeah. There's VG, and you can see there that we're selecting it up here, right? So the common notation here is just a short for doing multiple times this, right? So you can just like separate with commas the variables and their declaration. So SVG here is set to the SVG element that is in the page that is declared up here. And the text that we saw before is obviously part of it. And you see that the SVG is sized with relative sizing to take the whole screen. Yeah, so that's why we see it full page. And the background is red. So to get the white, we basically need to somehow comment this, right? Because the default background of the browser, if you're not in dark mode, then it's going to be white. If you're in dark mode, then probably you need to set the background of the page to white, otherwise it won't work for you, right? So here we're making some assumptions. Okay, so we do a transition on SVG, and what is the transition doing? Somebody that is in here or at home. Yeah. So, but you just look at the code. So, what do you think it's doing? Yeah. Yeah. So the way we hide it is that we set the visibility to hidden, right? So visibility is an attribute of the SVG, and so if you don't know what it does, you know, obviously you can just play around with the code here. And or in the inspector, I'm going to do it here for just the sake of the example. And you see that it displays there. It's hidden, so we're going to set it hidden. And we're going to look at the page, and obviously nothing is there, right? So we basically hide the SVG because the SVG has a red background and it disappears. So that's the only thing that we're doing, right? So this is a way to debug these things, to just go and play with the HTML. Otherwise, yeah, we can, well, actually, we can just get in here with the inspector, right? And you can do like this. So here we have the body. Inside the body, we should see the SVG. And here you see that we have the visibility hidden, and we're going to change it to, you can put the initial or inherit if you want. So this is the or unset, right? So all of those will give you the same result. That makes sense? Okay, so these parts we understand them. So this is just sizing the things, and I think we already discussed that. And then we just do here a simple select and append, because the SVG is already selected, and we add the rectangle for two rectangles for the vertical and the horizontal bar for the cross. You see that this color, what is this color again? This is specified as we saw this in class. So you have two ways to specify the colors, either RGBA or hashtag is not the name. It's is not a hash value. It's just a notation for hexadecimal. It's a base 16, and then you need to count by pair. So the per pair here is 0, 0. What does it correspond to in terms of color? RGB, yeah, exactly. It's exactly the same order that, so you could do this with RGB, and then we want to put 0 for red, green we want 255, and 0 for blue. Right, and this should give us the same thing, except that I didn't remove the visibility hidden here. Okay, I don't know what I think is the, yeah, this is, if you, here we go. Yeah, the sizing breaks obviously because I'm probably looking at just one of the axes. If you pull up the inspector, that's why the cross was not sized correctly. Okay, and here it turns white because we set up the transition, right? That is down here. So these two are the same thing, right? So this is with the RGBA notation, where the values are between 0 and 255, not 256. And this is the hexadecimal, where each couple of values goes from 0 to FF, 0 being corresponding to the 0, red, for the first couple. The second one is green. Here the FF corresponds to 255, that is the maximum value. And then you have the last one for the blue, okay? If you want to add the alpha, you need to add it here. So, and then you need to do RGBA, and alpha is between 0 and 1, right? So we can put 0, 3, and then you see that the top bar there is semi-transparent. Yeah. Now, in here, the 0, 3, you need to actually go and compute it or as on a 255 scale with the correspondence in hexadecimal, right? So you can go and look in the slides. I think I had the calculations in there. So it's straightforward, but the point is that if you use RGBA, then the value is encoded 0, 1, or here is encoded on the hexadecimal scale, right? So here, I don't know, 0.3 might be maybe 55. Yeah, that was good. Okay, get it? So okay, good. So don't get confused with those. Okay. Okay, we want to remove this, and then we'll go on. Okay, I think that the rest is obvious. Show logic to make it visible, and hide it after 15 seconds. So this is just there shouldn't be a backpack here, but you just make sure that you understand what is going on. But basically, we want to transition out after 15 seconds the visibility, so that we turn it back on and as needed. Yeah, so this is in, so you understand what is going on here? Yeah. Yes. So why do we have another time this we're setting it to hidden here? So what this do? What this code do? So here this is difficult. That as a selection, it does what? What is the dot on? No, we remove the SVG, we do it here. Right? So why do we do it again here? Right. So you remember that when we load this thing, it says press space to reset, right? So after the 15 seconds, if I press space, then it comes back. So this is what this code does, right? It binds the key down, so I can press any key, actually, not just oh, it's at this point it's any key, but then I check if it's really a space, right? And so I see if it's visible or not, and then I swap it, and then we make the SVG visible, right? So this should rather be something like this. And then there is this transition at the end. So why do we need to hide it again? Right, because at this point we make it visible, so we see the red cross. We're back to where we were here in the code, right? Where we have the green cross with the red background. And so now we want to set up a new transition, to wait 15 seconds and to hide it. Okay, that's all. Okay, good. So this one is easy. So yeah, so this one, two things, right? So one is understand how the code works. Two is understand how do you compute the after image colors from the image. Yeah, because I'm going to ask you that obviously in a quiz. That's the reason, right? So I'm going to tell you here, yellow and blue or whatever, one of these, and then you need to choose the others. And I'm going to give you a color model. So you need to use the additive one, right? Because the other one is for paper. And then you can predict with the secondary colors. All right. So yeah, and I guess that the third point is that if you don't believe it actually happens, you can go and experiment yourself. All right. Okay, so now we can go to EX2. Okay, EX2, and I'm going to pull it up here too. Okay, so this one is trying to understand color problems. So you see it gives you some instructions. I'll let you do that. I'm going to do an alternative, that is to use the other tool that is mentioned in the slides. But basically, what these tools do is that they allow you to emulate vision deficiencies. So the one that I'm going to use is the Color Oracle. Hopefully people see it there. I installed it. I think it works for Windows and Mac, so you can give it a try. Otherwise, the tool that is in DevTools that they put in last year is basically doing the same thing. The DevTools tools actually give you a little bit more information on what to do for these problems. So here you can simulate some of the common and rare ones. So you remember this one, the Deuteranopia is the red-green, and this is about 5–6% of people. The Protanopia is the red that is defective as opposed to the green. This is another 3%. So the first two more or less have the same output in terms of colors when it comes to red and green. And that boils down to about 9%. And this one is very rare. Most of all of those are for males. So the way you just work it is this way. Okay, so what is the trouble here? So here where you see that we're simulating the Terranopia, that is the green deficiency. Yeah. So what's the trouble with this visualization? Can somebody tell me? Idea? Does it look right to you, or what is wrong? Yeah, so what type of scale do we have here? So you remember you have the categorical scale. That's what we would use when you have categories that are different from each other, right? Then you have the sequential, that is a ramp of colors. And this one that is a diverging, right? So you have a center value that is called the critical value. And then you have two ends, right? And you use that when you have opposing data. So this could be an electoral map, or I don't know, so maybe, you know, how the weather is impacting these regions, we don't know. But these things are opposing, right? And so you want people to be able to contrast each side of the things. So you need to be able to differentiate the opposing colors. So if I look at this, the opposing colors here, you could say, right? If I figure this resolution, they're exactly the same, right? And so then this map is completely useless. Completely useless. I mean, the only thing that it shows is the absolute value of the problem, but you don't know the sign. So you cannot visually compare them. That's what is wrong, right? So, okay, so see if it's an electoral map, in other words, what it tells you is the number of people who are actually voting in these areas in majority for one of the parties, right? So do they vote a lot or a little for one of the parties? But you don't know which party, because with the color encoding kills it for people that are colorblind in this way. Now, if you can go and look at it with the other deficiencies, so you see this one is a little bit better in that the extremes seem to be differentiable, but that's about it. Yeah. The treat I know, this one is very rare, and this one, even though it's very rare, you see that it's pretty good here, right? So yeah, but again, this is very rare. This is 0.01% of the population. So yeah, most people, this is what they see, and then they can make sense of this, right? Okay. So you want to list them there? Do you see any other trouble in general with this map? No, not necessarily related to color. So you remember we saw two main things that. So there is the blurred vision, and there is the color encoding, right? That some people might not be able to get. So here I would say at this size, the text here on the scale is completely unreadable for most people, right? So there you have a question of size of the text that is not good, right? And the size on the map, I think it's okay because we can make sense of it. If you just want to give an overview, that makes sense. We see a little bit here that there is a kind of dichotomy where the top, the bottom part of the map is voted with the green shades mostly, and the top one is voted red, right? So in that sense, I think that the map is useful, but then the legend allows you to read the map, and if you don't allow people to read, here the title, because if the title is actually part of the, yeah, it's actually information is not in the main title, right? Because here it tells you that is the difference between 2015 and 2016. So this is actually comparing two elections. It's in Spanish. It's actually two elections for municipalities between the 2016 year and 2015 year. And they tell you what is the not the change in party, but the change in number of votes. Did they go over 5% or less than 5%, and so on, right? The only thing I would object is that you know this scale here, they just put the n values, right? And so you know I need to go and compute what the rest means, right? And then the critical value, what is it? Is it 0 or is it that they don't have the data? I don't know it, right? It can be both things. And with this color encoding, we don't know. Most of the time, when you do this data, sometimes they do it fresh after the election. So sometimes they don't have the data, and you have the kind of blank areas. But then it's customary to tell people what is going on. Yeah. Yeah, and then you remember that there is also this thing with the simultaneous contrast. So here it doesn't seem to be a big deal. I mean, we see that it's a little bit darker on the side, but at this scale, I would say that it doesn't appear that there is a variation, right? So for the variation to appear, you need to probably have a larger size color scale, and in that case, you know that how to prevent it is just to separate the cells for the keys with the white background, and then you don't have one color that is impacting the other. Okay, so I think that this is good. Okay, so now in DevTools, you also have these things that I don't remember now how to get to, but that tell you how to do the. So I think it's you need to follow here. DevTools menu, more tools. Okay, I think it's here. The 3 buttons, more tools, and then we want which one? Okay, rendering. Okay, so the rendering is 1. So I'm going to go look at this one. It's here. Where is it? It's somewhere here. Emulate vision deficiency. So you can do the same thing, and you see that you have also the blurred vision. Okay. So and you see they do a pretty good job because the blurred vision they also put it in the picture, right? So everything is blurred. So it's not just touching the HTML. And so you see that this page for people that are that have blurred vision, it's pretty much unreadable. Now, I don't think that the, okay, I want to stop this because otherwise we're going to get sick here. Okay, so I think here I wanted you to do two things. Accessible current standards. Yeah, okay. So you need to go and watch the video, and they explain you how to access it. Let me see if I can remember. So I can show you, but okay, no. I think it's maybe in is it here? So here you can get a report, but I think there is a way to the tools Chrome. We don't want to access Chrome. I don't know. Okay, I'll need to. If you don't find it, I'll look it up, and I'll try to post it. For some reason, I didn't put it in here. Don't perform maybe application. No, this is storage security lifehouse perform. No. Okay. No, this is the settings for Chrome. More tools, animation generator. Okay, so I'll look it up. Yeah, actually not. Actually not. I think it's just they're embedded in the tools. Now I remember. So the idea is, so we want to go to 2. Okay, and then I think it's embedded in here. Accessibility here. I think this is it. Okay. And I don't remember how to do this. I'm sorry. Compute property. No. Is that right? Oh, so yeah. So okay. I'll look it up. But there is a way to access the color, and then you can dynamically change the color, and it tells you the level for which you are attaining the AA standard or the AAA standard. So the AAA is that you have a contrast ratio that is 4.5 to 1. The AA, I think it's less than that. It's 3 to 1. So no, sorry. The 3 to 1 is single. It's written here. AA is 4.5 to 1, and AAA is 7.7 to 1. So the AAA is usually what people use for medical applications. Everything that has to do with health questionnaires and pictures that the patients need to look at, that's what you want to use, because they might have vision deficiencies and or blurred vision, and you want to achieve high contrast color in everything that you present to them. Yeah, so for this, I'll try to do it during the break so that we don't lose time now. But basically is to go and find a color that matches the AA standard at least. Okay, so 3, and now we're moving to D3. And we're starting to try to understand a little bit how the scale works. So the color scale is basically the same thing as a regular scale. So in D3 and in general, so you go from your data, that is the domain, to the representation, that is the range. Okay. So the domain is your data. The representation for colors is some colors, right? And you remember that what is a little bit tricky is that you don't want to start playing around with colors. So you don't want to create your own scale most of the time. And so the scales that are in the field, they help you set them up. Okay. And so we're going to see how the different scales are useful. But then the D3 gives you a number of schemes. You see this D3 scale chromatic that we're going to go look at. And that gives you good color scales to use for in practice for application. So this one here is just to go into the text and try to understand how the mapping is done between the data that here is shown with the numbers, right? So I'm mapping 0 to 1 with the scale to the color, because the colors are the output of our scale, right? So that's the range. So don't confuse with the scales that we use for the axis, because there the range is the length in pixels for the graphic. So the linear, it does just a linear interpolation as you would expect, and you see that it plays with the gray level. Sometimes you might want to compute this if you want to have lighter colors for some of the data. This is not necessarily useful if you want to use it with transparency to avoid overplotting. So when you do the overplotting is the problem where you end up plotting several times the same data points on one on top of the other. And in that case, if you don't use transparency, then you don't know if you have 1 or 1,000 points, right? So the way to go about it is to set the transparency on the dot color. And then when they pile up, it's going to just become darker. So, and there what you're doing is just a linear interpolation, but it's done visually and automatically. You don't need to use a scale for that. But if you do a heat map and you want to use a linear scale, that would be a good way to go. So electoral maps, for instance, or maps for employment, you might want to use a linear scale. Now, when you want to be careful is when you have keys. So the linear scale, you have continuous data. So if you look at maps for unemployment, then you can map the count directly to a linear scale, and people are going to be able to make the difference. If you have categories or you segment your data in different unemployment ranges, and you want to associate a color for each range, then you want to be careful that the color can be dissociated, because the information there that is important is the categories, right? And in that case, that's really when you want to go and use the D3 scale chromatic. The scale sequential, you see the description there. It basically creates a scale with domain and an interpolator function that is the one of these degree scale chromatic. So we can go and look at that to understand what these are. Okay, so you see the first thing is that this is D3 scale chromatic is a part of D3, right? So it's a library that is part of the D3 ecosystem. And here you have the documentation in the README, as is usual with D3 and other projects. So they usually start with some examples and some general information on how these are built and how to use them. So here you see that this one is useful. This interpolator are going to be useful with scale ordinal, that is categorical scale, and then the scale sequential that is here. So if you want to know more about the schemes here or the interpolator, then you need to read on down here and then look at the example. With the example, these are the list of all the schemes and interpolator that you have. So the difference between the schemes is that the schemes are set of colors that are predefined that you can just go and use. And the interpolator, they do what they tell you is that they interpolate between color values. So these ones are continuous, but it doesn't mean that you need to necessarily to use them like that, right? But usually if you need a color scheme, then you would pick from the array, right? Because these are mostly used for continuous data. Typically the example of unemployment counts or temperature and so on that you would associate with a continuous scale. Again, unless you bin basically your data and then you assign categories to them. And you have a bunch here to pick from, and you see that you have that are single U, such as these ones here. So they go from white to a given color name. This one is an achromatic one because it goes with the gray, white to black. And then you have multi-use. The multi-use, what they do is that they interpolate across multiple colors. So you see that here we go from black to blue to green to yellow to orange and to red, right? This one seems to be between black, blue, green, and yellow, and so on. Okay. So depending on what you're doing, you may want to use one of those. Again, most applications that are with specific data, they will prefer that you use some color interpolation scheme that is already customary for people to use. So, and you should be able to find it in here. Okay. Yeah, the rainbow is nice. Okay. So this is one way to go and get these things. The other way for categorical is to go look at color brewer. And it's the 2 because I don't think they have a 3, but here it is. So this one I can show you how this works. Okay, so it's a kind of menu where you can go and select what you need for your visualization. So you start by the number of classes, and you see that It only goes to 9, really. And usually this is the case because these again are optimized, so you can make a difference between the colors. If you go much more than that, then it's hard to actually create a scale that has meaningful differences between the keys color. And that has all the properties that we're going to see. So in that case, you really need to think harder if it's really what you want to do, because even if you get such a color scale, for people it's going to be very difficult to use, because we can only remember associations between 5 to 7 colors, and otherwise we're reverted to a mode where you need to go look up the color and then look up the display to make the association between the color and the data. And this is just time consuming. So maybe the form itself is not well adapted. So here you have the 3 types of scales that we've discussed. So the sequential is what we see here, right? So it's a sequence between here a single hue colors, right? That go from white to some other color or washed out version of white. Those would be the one at the top here, or sorry, in the right side, and then the multi-hue that are here on the left side that use different colors. Yeah, so it's not immediately clear, but you see that here we're using the orange and the red. While here they're just using blue and some white or bluish white. Okay, so here we're staying with blues, here we're staying with green or greenish white, and this is the achromatic one. Well, these, you see that they're mixing up the green and the blue for this one. Here we're mixing magenta with something that looks like a blue, and so on. Now these you can pick to be divergent, and all of these are usually most useful with maps. That's why this is showing you how it looks on a map. And if you're actually working on a map, then so this type of map is called a choropleth map, because areas are colored based on some value. And so here you can set up other properties of the map in case this is what you have and you want to get a feel of how other colors would do with a given color scale, right? So yeah, so here, for instance, yeah, so again, it depends a little bit of the data, because here you see that one of the keys here is red. Now we don't have any red in the data here that has been shown, but if you add any red, then it would interfere with the color of the layer for the I think is the highway system here, right? So that wouldn't be a good choice. So I guess that's why they provide you with this choice. Now today we're going to see this next week, but most of the maps they don't. They use the systems that are online that provide you with SVG maps, and you can customize them with different themes. So you can mix the layers with different themes, so you can get around these problems. Yeah, so these are usually don't touch them. So here you can see the free keys, because we asked for free, right? So you see that these scales, they have more. And here we have the critical value in the middle. I think there is a way to say that we don't want it. No, there isn't. You just need to take it apart. Obviously, if we put 5, it's just going to scale up, right? And here we have the hexadecimal representation, but you can also get the RGB and the CMYK if you want to. So this is cyan, magenta, yellow, and K is for the intensity. No, sorry, K is for black. Okay. And then here you have the qualitative scale. Okay. Now you see that if you use this interface, basically you're stuck getting these values, putting them into an array, so you get your scheme that you can use for the colors, right? So, and that's exactly what D3 is providing you with here through this D3 scheme sets that are actually available through this D3 scale chromatic for the color brewer scales. Okay, so we're going to see how to do that next, and it's basically what I've explained. So you can go in color brewer, try to pick a scale, and then try to find that scale in D3. So the way you do it is very simple. The D3 scale chromatic is already loaded in here. So you can just go here. Yeah, so this is happening because we need to set some code for this to work. So as soon as you set the code, the error is going to go away. So here you can you have access to all the variables because the free scale chromatic is already loaded. You see that they show up here. So you have the scheme yellow, green, blue, CVDs, etc. that we saw in the page earlier, right? So I'm going just to pick the first one. And you see that it's a bunch of arrays, which is not what you would expect. So we're going to see why. And the reason is that they give you all the choices between 3 to 9. So that you just pick the one that you want. So if you want to say to pick a scale with 5 colors, you just go there and you do, because this is an array of 5, right? And so you get your scheme ready to go. Okay. And again, this scheme is what you just use here. You can look in the code to set up the scale. Okay. So we can look at the code, but basically it's what it is. And I give you here. We want to use a scale ordinal because we want a scale 4 categories, right? So the ordinal will do it. So here you can get the scale name in color brewer. I don't know where they actually show it. Yeah, so here as you see 5 class accent. You see here set 1. So this is the name in set 2 in color brewer and set 3. And so you should be able to find a similar one in here. Yeah, you see scheme set 1, set 2, set 3. You see? Okay. And those you see that they're unlike the others. They come up with just an array of 9. So if you need 5, you need to go and pick them apart. Okay, good. So here the idea is how do we fix? I think this is what it is about. Yeah, how do we fix the map that we looked at previously? And so the way you do it is very simple. You go and find in color brewer a scale that is colorblind safe, which you can do here. So if we need 5, I think it was 5. So yeah, colorblind say we're out of luck. Oh, we're qualitative. We went at diverging. Yeah. So these are the scale that Color Brewer proposes to you. So you see that they have a kind of a magenta green as opposed to red green. And this one, again, if you want to make sure that it works, you can either go with this tool, right? You see that they actually are color safe, or you can go with the DevTools tool to double check that. But you can trust them because they've been working on this quite diligently. So if they tell you that it is going to work, it's going to work. So again, colorblind safe. You get your scale colors here. You see the name there, and then you try to find the same in D3. So you don't need to go and copy these values. Is that clear? Okay, cool. So this was a diverging color scale. Here is a sequential color scale. And we're trying to do a kind of heat map. So that we want to color the data based on the scale. So you just want to go and basically do the same work that you've done here for this one. And I think in the code I give you the solution. Obviously here is going to be sequential, right? Yeah, so you see here you have scale ordinal, and that's what you need to put here. Here we want a sequential color scale, so you need to go and look at D3 here. The documentation is there, how to do a sequential color scale, which you just say scale.sequential, and you want to use the single U, a single U interpolator, and then you should be good to create this 1D heat map. So why is it a 1D heat map? Why do I call it like that? Because the data are going to actually yeah, maybe let me, I can show you the solution so we don't spend too much time on this. And so you see also what it looks like. Okay, we're looking at 3, right? No, that's the wrong one. This is the one that you're doing. You need the 7. Here, this one. This one is good. npm run serve. Here we go. Yeah. So the gray bands there are things that are not seen, and the data are actually filling in with the color, right? So here I took one of the orange scales to do this. Yeah, I used the interpolate oranges, and that did it. Yeah, so it's very, very straightforward. You don't need to do the lollipops there. I'm doing it so that we don't put the solution in. Okay, the last one is just a categorical color scale, and yeah, that is colorblind safe 4 keys. So I picked this one. You can pick whichever you like, and then go in the code and set it up. Okay, which is also straightforward. If you have questions, we can go and discuss them. 307. Yeah. So I'll make a break so that we have time for a break a little bit, and then we'll resume with that. Okay, so I'll continue now. Yeah, so I remember now to change the colors here and look at the level. So what you do is that you call in the dev tools. You go with the arrow selection here on the page to select here we want to change the color in the text. So you can see that here in the pop-up you have some information about the contrast. They have this 10.1. Oh, okay, thank you. Share screen, share screen. Okay, I guess I'll repeat that. Okay, so in DevTools, you use the selection tool to go over the text that you're interested in. And you see that there is accessibility information on the pop-up that comes out. The 10.1 is a 10:1. Your little thumbnail for the text that tells you what is the foreground and the background, and the green check mark saying that this is good. Now, if you want to actually set it dynamically, you want to select the text, and then you come here to the color, if it's what I did before. Whoop. Okay, and in this dialog here, you see the same information that you can open up. And there they show you the AA and the AAA, and you have the links that tell you what they are. You can use the sample of the picker here to pick a different color. So we're going to say use this one. And or just move the dot here around. And you'll see that the AAA thing here changes depending on when you are with the color, right? So and the color contrast. The line here is the separation between, I think, the AA. You see the AA goes away, and here it comes back. And for this particular color that we've picked, right, we don't seem to be able to do any better than the AA. But to get to the AAA, we would need to use different color combinations. Okay. So that was it for the accessibility. So now we'll get back to, I think we finished the 3, so we'll get back to 4. Okay, so these are, we're basically done with the colors. So these are just things that are complicated to do with D3. So D3 gives you either a generator or something that allows you to set up the layout so that you can do some of these graphs. So 4, 5, 6, 7, and 8 are just about that. So 4 has to do with the area chart. I don't think that we saw this, or maybe we saw an example already, but we didn't go through the code. So this is what it's about, is to go through the code. And here you have a little bit of an example of how this is done. So this is how the generator works on one slice here of data between 2 consecutive values, right? So if you think about a line chart, we would have a value, say here, and then a second, the inline segment that would follow up here. So let me blow this up. So supposing that these are the 2 line segments, if we do a line chart, then we need to generate the line between the 2 points. If we want to do an area, we need to actually create this area shaded. And so with the area chart, with the line chart, what you get is that you create basically a pass for or that connects all the points for the line, either smooth or not. Here is straight lines. And then you do a data join with just that element as the datum, right? If you want to do an area chart, then the way it works in diffie is that you basically use a different generator, that is the area generator, that gives you an example here between 2 points that creates the area under the curve. And then obtain a pass that is basically the whole area that is shaded here in blue. And again, you do just a single data join with that area, and you're basically done. So that's a little bit the idea. So here we do in the part 0, we just play around with the area generator to create this. I don't know if I'm showing you the answer or not. I don't think so. But yeah, you want to go in the code, then maybe we can do that quickly and see what is there. ex4.html. Okay, so there is just explanation really, right? So and that's basically what I told you. Now for the you know more or less what happens with the line generator, because we looked at it. Here the area, you see it's a little bit different, and you need to specify where the area starts in Y, that is the bottom of the polygon, and then where it ends in Y, right? So that's why you have this Y0 and Y1. So before you do that, you want to go and look at the doc for the area generator, and you see that I put here a link that you can also see in the page. Let me just keep this on the same screen so we don't need to swap around. So, and let's see if I did it right. So it opens in a new window. So you see here the top line and the baseline for Y0, for Y1 and Y0, and so on. So take a look at the docs here, and they have some examples that explain you how they work, that are simple enough. You see that this is basically what we're doing. Before you answer the question, so you understand how to use it. Now, this is the way in which you would proceed if you want to use anything else that has a generator, right? So here we did it with the line, we're doing it with the area. So if you want to do something else, then you go and look at an example, then you look at the docs, and then you try to modify it for your needs. Yeah, so yeah, I'm just I took something from the website that the three had before. I don't think that this is actually still there. Let's see. Yeah, so they've archived it, but it's here. Okay, so it's not the same. I use different data because this is out of data. So I don't know if I subsample the data, probably that's what I did. But it is basically the same code base that is there. And now these things are inobservable. So this is the last of the exercises, how to go and use this. So this one is a generator. This is another type of generator. This is for doing histograms. So when you want to do an histogram, you want to create the bins. So you need the bin generator. And you can go and read here how it works. Here we go. Okay. Then this one is actually, so this is an observable, and it has this this interactive visualization where you can play around with with the visualization, I think I don't remember if it's one of these. I think it is oh here. This one is interactive, so you can see here. I think the parameter is the domain for the bin, right? And so you see visually what happens. You're including more or less points because most of the time when you want to do the histograms, you don't want to put the outliers in there. So this is a kind of finding a natural cut point for the number of bins that that you want to create based on the highest value in the data, and drop everything else that might be an outlier. So if you look in there, it's fairly obvious how it works. The bin generator, basically you need to give it to pass the data and then configure the number of buckets that are going to be useful. And you have different ways to do it. So in the code, it's you just want to experiment a little bit and see how that works. So you know how to use this type of code. If you want, we can take a look quickly at the example. In the page, so here you see that I've been nice. I put there the link to the documentation page. So it is the page that we're looking at, and then the section that you want to go and look at before you go and put the explanation, because it explains to you how they work. In particular, I think that the threshold is indicative. I don't remember, but there are some quirks with these. The rest I think is just once you have the bins, then it's like doing a bar chart with counts, right? So this code is immediately obvious to you. It's just doing the bar chart with a little bit of aesthetics to make it look nice, but that's basically it. So the nut of it is just this part. So here you can go and see the explanation for the scale, the nice that gives you values that are rounded, so that your scale looks nice, and you can put a little bit of explanation there to make sure you understand it, so you can also use that feature in the graphics that you create. Pie chart, not unlike the area chart. So here it's a little bit different in that we have a radial layout, and what you need to do is map your data to a pie where the area is corresponding to the value, right? And here you see an example also from one of the old website, I think. Correct. This diffree chart, I updated diffree, so this is using the latest diffree. And the code that is in here is obviously in the page. It's not the one that is up here. Some of it, I think, these have been redone in observable, and the point here is that they're not being maintained anymore. So you should go and look at the example in the tutorial in observable. And again, we're going to see how that works. So the pie generator is a little bit more complicated than the area generator, because you need to create the pie segments and then you need to put them together. So the explanations, we can take a look, but So it's a little bit more dense in terms of what you need to look at. So the arc is you can go and look in the documentation here, right? So the arc generator basically creates a pi of the chart, and then the pi can start at 0 or start at some radius and then end at some other radius, and all that obviously you can configure it. And so the way you configure it, you see, is with the inner radius and the outer radius. So if you want a regular pie chart, then you put the inner radius to 0. You see that the way you configure it is just of passing an object with these properties. If you use an inner radius that is different from 0, then you get what is called the donut chart. Usually with this, what you do is that you end up writing some text in the middle, and you use multiple of them. Say if you want to do a pie chart for 2015, then you're going to put 2015 in the middle, next to a pie chart, a donut chart for 2016, and you're going to label it with 2016 in the middle. Yeah, so, and then the start and the end angle, right? So because each pi of the chart starts at some angle and to end at some angle. So there is some trickiness there that is about computing the angles. Obviously, D3 uses the arc generator, but you don't need to actually manually go and compute the angles. Okay. Okay, so this is just setting up so we just create this arc generator. Here you can see what the slice is, and you'll see that if you log this out, that it's a pass, similar to the error chart that we saw earlier. Here we're setting up the SVG. And this is the simple example that is at the top. So we basically create one slice, right? So it's fairly simple. Here, what we do with an actual pie chart is that we need to create the pie, and so the pie is a layout. And that's different from the generator. The generator allows you to generate the areas, and the pie allows you to put the areas together so that they work as you expect. So that's a type of what I called in the slides a layout generator. For the pie, we're going to see a few other layout generators next. If you want, you can have your pie sorted, right? So for that, you need to sort the data that go into the pie, and here this is the way you can do it, by providing a comparator function that sorts the data, and then here you can sort them based on that. Yeah, so the comparator function, I guess you've guessed it. If you don't provide it, then you're going to get a default, is what is happening here. And here we're setting a default based on age, right? Because the data are coming as an object, so we need to explain which part of the object we want to sort based on. This part here is just for configuring the arcs. And then we put it together with the layout generator here, saying this is our data, and for each one of the data we want to create a pass, and the pass, you guessed it, is based on the arc generator. Okay. Yeah. So it looks a little bit difficult to read because you're doing this data join with the pass, but at the same time, you need to use some layout. So the layout here is as you can see, it reorders the data so that the pies are going to come out in the right order, right? And then so that's the job of the layout. And then the pass knows the pass here. I think what you get with the pie generator is that the pass is set up in a standard position. Then the layout generator is going to take it and spin it around so that you can actually realize the whole pie chart. Yeah. So you can verify that if you print out the values, but here you see that pass is, what is it pass here? Can somebody tell me? Is that the actual pass that we get when we do d3.arc? So this is a pass generator, right? And here what we're doing is we're just configuring it, right? It doesn't know about the data yet. So this is just a function. And it's going to, and here when we do the data join, we say we create this pass, and the pass, the attribute D is going to be computed by this function. Yeah, is that clear? So here, this function, the d3 arc, we configure it with inner radius of 0. So here, if we put a inner radius of 50, where is our friend here? I think we are on 4. No, we're on 4 here. Yeah, right. So we see a all, right? So I don't know what are these data, but I guess if we put 100, we're going to have 150. Okay, so we're getting the donut chart, right? And here all I'm doing is just configuring the pass generator, and then the layout is going to sort out the data as we want them, and use this arc generator to create every pie. And I think that's about it. Yeah. So this is a little bit. Can somebody explain this to me? The later part. So as always, the first thing is if you don't understand the code, you just understand a little bit what it's doing, right? So this is adding text, right? So you go and look in the figure. So the text is this text, right? So where is the text located? Is it in the center of the pie angle-wise, right? In each segment, it's in the center, but it's not in the center of the pie area. It's on the center radially, right? For this pie, the center is the angle that bisects it, right? So what we need to do is, and then there is a radial component here. So it's in polar coordinates, right? So we have some distance and some angle here, and we need to find where that is, right? And so this code is basically doing it, and you see that we're using this centroid. So the label here is you see that we set it to the arc. So we use the arc generator for the label. And here we configure it so that the radius, so we're not using the arc generator to create an area, but we're using it to place the text, right? And so we configure it where we want the text to go. You see that these values are set up the same. So this is just one location radially from the center. And all we need to do is find out which angle the center needs to go, right? Because we're doing the data join with the arcs that form the pie chart segments, the pies, then this is going to do the same. So the label is going to be for each one of the pies. Yeah. And so all what we need to do is know what is the center of the pie, angle-wise. And so centroid is returning this. If you look in the documentation, that's what it does. So we get it middle of the segment. Okay. So it's a little bit complicated, convoluted to do, but once you know how it works, you say, okay, and the only thing I need to do is go and set up this radius. Okay, so here the change to a donut chart, I did it, right? So you don't need to, if you want to leave this to 0, right? This will work the same, right? 150 or let's put 200. Right? I can just, because this is the definition of the function. So if I redefine it with var at this point is good enough. And right? So it is not more complicated than that. 7. Same thing again. This time we're doing something complicated. That is what is called a chord diagram. So here the data are in a matrix, and what it shows is proportion of one category with respect to proportions in another category, right? So the value is in the matrix, and it's encoded here by a ribbon. And so this ribbon, you guessed it, is a pass, and this is a layout. So we need a a ribbon generator, similar to what we did with the pie chart. So with the pies, we had I don't remember what we called it. Where is it? The arc generator, right? So here we're using a ribbon generator, and then the layout is not like a pie chart, but it's like a chord diagram. So the layout is going to take care of the rest. Okay. So this one is a little bit more complicated code-wise, but it's the same philosophy. ex7.html, and again, it's mostly about understanding how it works. You know, it's very easy to just configure the generator here for the ribbon. You have a ribbon generator, and then a ribbon that has a direction. So if you do this, then you will see that you get a direction here. You saw it. So the ribbon goes from a starting point to an end point. And so if you want to have these directions, then it's probably as easy as to go and use a ribbon arrow somewhere in here. That is, I guess, here. Here we go. Yeah. So it's that simple. Once you understand how to change things, it's very quick to do it. Okay, so I think you can go and look at the different pieces, and we've mostly explained everything. Yeah. So this one is more complicated because the layout is you see you need to set up every little bit of it because it's using this data here on the side, but that's kind of additional work that was done on this plot. Okay, so that part is just for the ticks that are the labels that are on the outside. Okay, I think this is okay. Yeah, so here I basically gave you the answer, and so you see it's really a matrix data that is shown here, where you want to show relations between categories. Okay, so then this one. Okay, so this is the last one, and I'm going just to show you maybe the top part, because the bottom part is really cut and paste once you understand it. So the observable is basically a notebook that is online, similar to Jupyter. So instead of doing Python, you do JavaScript. So the interpreter is Node as opposed to Python interpreter. And so the way you write things is a little bit different. So if you want to use it to generate things online, you do the observable way. But if you want to use the code into your HTML page, you need to adapt it. And so here I put side to side how things look. For a simple example, that is the one that you show here with the 3 dots. Okay. And this is actually the same thing that happens with any other observable code, right? So the structure is going to be the same. Now the pluses here have to do with, you need to go in observable, and here we're going to go and look. So yeah. So what I want you is to redo this with exactly the same, and then you can. I think it's in the homework to redo it with the with your data. So what you see here is you see the same structure, right? So it starts with this chart object. You define the chart because the notebook knows then how to show this, right? So it's right here. And the chart basically is the code that is going to be rendered. So because this is Node, you need to tell Node to create the SVG. So I don't know how observable does it. If they do it in the backend, they probably have a virtual DOM that they use to execute this code. And you see that here they get the node, so that they can paste it in the page, and you can actually see it. Okay, and this is the node in the DOM tree that is either they're attaching to the DOM on the client, or they're doing it on the server, and then no, they're doing it on yeah, I don't know. You can do both because it can be interactive in both ways. I don't know what is the strategy that they've used to implement it there, but still, this is the code that you have to work with. Now you see that this is the top of the file in observable, but in your case, it's really the bottom piece of code here, right? That is corresponding, where you set up your SVG because it's already there. You know how to create it dynamically also and do the same thing as here. Here they're using the viewport, the view box, because they want to set it up inside this SVG that here doesn't exist, that is created by observable. So basically, the only thing that you need to do is change this code for the SVG to either an SVG that is already in the page that you select and size, or that you create dynamically, right? And there the parameters are just width and height. And then you execute your SVG code that is here. Okay. Now the join is you can look in the documentation. This is a simple way to do the data join. That does what you expect in most cases. That we didn't see, but it's going to be straightforward if you understand now that you understand the data join pattern. Then what follows here is really the configuration part and the getting D3, right? So and in your code, HTML code, then this is coming at the top. Okay. So the reason why they do this in observable with this reversed way of doing is because I don't want to show this one, and I'll conclude on this. Zoom, wait, I think no, it's not this one. Pi, yeah, it's this one. Is because they want in the notebook to have the chart at the top, right? So they start at the bottom. So that's why it's reversed. Okay. So for this one, you see that the code that you want to reuse is this one. And you'll see that you might run into trouble because there are a couple of things that you probably don't have. Where is it? I think no, I think you have everything. Yeah. I mean the node here, you don't need to do it, right? Because it comes. You do need to copy the functions because the functions are used in the code here to do the interactivity because these are zoomable. Yeah, I was thinking that you needed something else. Oh, you need the data, right? So the data, you can go and scrape them in the file where they're declared. Okay. That is, I don't remember where it is. With Spark data. No, here. Oh, here, flare to the JSON. Okay. So you need to go get this file. And there is so here you can run the cell, but there is a touch file. No, we want to yeah, I'm over time, but there is a way. I don't remember if it's here to get the data. Maybe it's in the attachment. Yeah, it's here in the attachment. You see there, flare to the JSON, so you can get the data, right? So obviously the data in your code, you need to, it's a JSON, so you need to do a d3.json and wrap this code into it, right? In the .then, you paste this code and it should work once the data is available. All right? So it's not very complicated. It's just a cutting and pasting code, but doing it at the right spot. Right? I think we're done.